Chapter 1. Number System. A number is a fundamental mathematical concept used for various purposes, including counting objects, measuring quantities, and labeling items or values. In mathematics, all numbers are categorized into a set known as real numbers. In the context of digital computing, data or information, any audio, graphics, video, text and number is represented using binary numbers. The total number of digits in a number system is called its base. Children will be able to understand number system and identify its types, understand conversion of one number system into another, understand bits and bytes.
Neha.
Hey Tia, I'm interested in learning about number systems. Do you have any idea about it?
Tia.
Yes, Neha. Number systems are essential. Let's start with the basics.
Neha.
Why are they important?
Tia.
Number systems are the foundation of math and computer science. We'll begin with decimal, the one you already know.
Neha.
Decimal, like regular numbers.
Tia.
Yes, decimal uses 0 to 9 digits. Then we'll explore binary 0 and 1, octal 0 to 8, and hexadecimal 0 to 9 and A to F.
Neha.
How can I convert decimal to binary or hexadecimal?
Tia.
We'll cover that in our chapter. It's easier than you think. Let's start now.
Neha.
Thanks, Tia. I'm excited to learn about number systems.
Tia.
You're welcome, Neha. Let's dive in together. Numbers play an important role in our daily lives. They help us to count and perform various calculations. In ancient time, when there was no formal number system, people used various units and methods for counting and measuring. Over time, number systems developed independently in different regions of the world. Today, we have 4 primary types of number system. In this chapter, we will learn about number system. But before we get into that, let's first understand the concept of number systems in the context of computers. When we type some letters or words, the computer translates them in numbers as computers can understand only numbers. A computer can understand the positional number system where there are only a few symbols called digits, and these symbols represent different values depending on the position they occupy in the number. The value of each digit in a number can be determined using the digit, the position of the digit in the number, the base of the number system, where the base is defined as the total number of digits available in the number system. Number system. The method to represent and work with numbers is called number system. Decimal number system is the most common number system. Other popular number systems include binary number system, octal number system, hexadecimal number system, etc. Number system. Decimal numbers base 10, 0 to 9. Binary numbers base 2, 0 to 1. Octal numbers octal 8, 0 to 7. Hexadecimal numbers hexadecimal 16, 0 to 9 and A to F. Since the computer is made up of electronic components, it can have 2 states, either on 1 or off 0. The data which is given to the computer is converted into binary form because the computer understands only binary language. Binary number system consists of only 0 and 1. It further converts the binary results into their decimal equivalent for output. Decimal number system. Decimal number system is a base 10 number system having 10 digits from 0 to 9. This means that any numerical quantity can be represented using these 10 digits. Decimal number system is also a positional value system. This means that the value of digits will depend on their position. Let us take an example to understand this. Say we have 3 numbers 734, 971 and 207. The place value of 7 in all three numbers is different. In 734, place value of 7 is 7 hundredths or 700 or 7 multiplied by 100 or 7 multiplied by 10 square. In 971, place value of 7 is 7 tenths or 70 or 7 multiplied by 10 or 7 multiplied by 10. In 207, place value of 7 is 7 units or 7 multiplied by 1 or 7 multiplied by 10. The weightage of each position can be represented as follows. Whenever we want to derive the numeric value of a number, we need to see the place value of that number. The place value, the face value and the base value of a number decide the numeric value of that number. Example, 245 or 245 with base 10 can be expanded in the following way. 5 into 10 units equals 5. 4 into 10 tenths equal 40. 2 into 10 hundredths equal 200. Here, we observe that the value increases 10 times as we move from right to left one by one. Binary number system. All the computers use this number system during their operations. They convert the decimal input into its binary equivalent and further convert the binary result into decimal output. Features of binary number system. This number system consists of only two digits, that is 0 and 1. It has base 2. Example, 101 with base 2, 1101 with base 2, etc. Fact corner. The base of the number is always written in the subscript. For example, 110 with base 2, 458 with base 8. The easiest way to vary instructions through electric signals is two-state system, on and off. On is represented as 1 and off as 0, though 0 is not actually no signal but signal at a lower voltage. The number system having just these two digits, 0 and 1, is called binary number system. Each binary digit is also called a bit. Binary number system is also positional value system where each digit has a value expressed in powers of 2 as displayed here. 2 at the power of 5, 2 at the power of 4, 2 at the power of 2, 2 at the power of 2, 2 at the power of 1, 2 at the power of 0. In any binary number, the rightmost digit is called least significant bit, LSB, and leftmost digit is called most significant bit, MSB. 11010. And decimal equivalent of this number is the sum of the product of each digit with its positional value. 11010 with base 2 equals 26 with base 10. Octal number system. The octal number system, or oct for short, is the base 8 number system and uses the digits 0 to 7. Features of octal number system. This number system consists of 8 digits, that is 0 to 7. It has base 8. It can be converted into decimal number system. Example, 5010 with base 8, 50345 with base 8, etc. Octal number system is also a positional value system where each digit has its value expressed in powers of 8 as shown here. Decimal equivalent of any octal number is the sum of the product of each digit with its positional value. 7268 equals 470 with base 10. Hexadecimal number system. Hexadecimal number system has 16 symbols, 0 to 9 and A to F, where A is equal to 10, B is equal to 11 and so on till F. It has base 16 and can be converted into decimal number system. Example, 3E8 with base 16, 186A0 with base 16, etc. Hexadecimal number system is also a positional value system where each digit has its value expressed in powers of 16 as shown here. Decimal equivalent of any hexadecimal number is the sum of the product of each digit with its positional value. 27FB with base 16 is equal to 10234 with base 10. Let's quickly recapitulate the types of number systems with examples. Binary number system, base 2, use digits 0, 1, example, 11110000 with base 2. Octal, base 8, use digits 0, 1, 2, 3, 4, 5, 6, 7, example, 360 with base 2. Decimal, base 10, use digits 0, 1, 2, 3, 4, 5, 6, 7, 8, example, 240 with base 10. Hexadecimal, base 16, use digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A10, B11, C12, D13, E14, F15, example, FO with base 16. Conversion of number system. As you know, decimal, binary, octal and hexadecimal number system are positional value number systems. To convert binary, octal and hexadecimal into decimal number, we just need to add the product of each digit with its positional value. Here, we are going to learn other number conversions among these number systems. Decimal to other base systems. Binary, octal, hexadecimal. Step 1. Divide the decimal number to be converted by the value of the new base. Step 2. Get the remainder from step 1 as the rightmost digit, least significant bit, that is LSB, of the new base number. Step 3. Divide the quotient of the previous divide by the new base. Step 4. Record the remainder from step 3 as the new digit to the left of the new base number. Repeat steps 3 and 4, getting remainders from right to left until the quotient becomes 0 in step 3. The last remainder thus obtained will be the most significant bit, MSB, of the new base number. Converting decimal numbers to binary numbers. Example, let us take the decimal number 45. Write the base of the number just outside the close bracket, like this. 45 with base 10. This would make it easy for you to recognize which number system you are working upon. Example 1. 45 with base 2. Hence, 45 with base 10 is equal to 101101 with base 2. Example 2. 265 with base 2. Hence, 265 with base 10 is equal to 100001001 with base 2. Converting decimal numbers into octal numbers. The conversion of decimal to octal is similar to the conversion of decimal to binary. The only difference is the base. In this number system, we have to divide the decimal number by 8. Example 1. 2568 with base 10. Hence, 2568 with base 10 is equal to 5010 with base 8. Example 2. 20709 with base 10. Hence, 20709 with base 10 is equal to 50345 with base 8. Converting decimal numbers to hexadecimal numbers. The conversion of decimal to hexadecimal is similar to the conversion of decimal to binary and decimal to octal. The only difference is the base. In this number system, we have to divide the decimal number by 16. Example 1. 1000 with base 10. Hence, 1000 with base 10 is equal to 3E8 with base 16. Example 2. 1000000 with base 10. Hence, 1000000 with base 10 is equal to 18680 with base 16. Decimal number 45 with base 10. Calculating binary equivalent. Step operation. Result remainder. Step 1. 45 divided by 2. Result 22, remainder 1. Step 2. 22 divided by 2. Result 11, remainder 0. Step 3. 11 divide by 2. Result 5, remainder 1. Step 4. 5 divide by 2. Result 2, remainder 1. Step 5. 2 divided by 2. Result 1, remainder 0. Step 6. 1 divide by 2. Result 0, remainder 1. As mentioned in steps 2 and 4, the remainders have to be arranged in the reverse order so that the first remainder may become the least significant bit, LSB, and the last remainder may become the most significant bit, MSB. Decimal number 45 with base 10 is equal to binary number 101101 with base 2. Other base system, binary, octal, hexadecimal to decimal system. Step 1. Determine the column positional value of each digit. This depends on the position of the digit and the base of the number system. Step 2. Multiply the obtained column values in step 1 by the digits in the corresponding columns. Step 3. Sum the products calculated in step 2. The total is the equivalent value in decimal. For example, binary number 101101 with base 2. Examples. Example 1. Binary to decimal 100101 with base 2 is equal to 37 with base 10. Example 2. Hexadecimal to decimal 25 with base 16 is equal to 37 with base 10. Example 3. Octal to decimal 37 with base 8 is equal to 31 with base 10. Fact Corner. Numeric code is known as ASCII, American Standard Code of Information Interchange Code. Operations on binary numbers. In the binary number system, there are only two digits 0 and 1, and any number can be represented by these two digits. The arithmetic of binary numbers involves binary addition, binary subtraction, binary multiplication, or binary division. Binary arithmetic operation starts from the least significant bit, that is from the rightmost side. We will discuss the different operations one by one in the following. Binary addition. The result obtained after adding two binary numbers is the binary number itself. Binary addition is the simplest method to add any of the binary numbers. It can be calculated easily if we know the following rules. Rules: 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. 1 plus 1 is equal to 10. Rules for binary addition. Case 1. A plus B. 0 plus 0. Sum 0. Carry 0. 2. 0 plus 1. Sum 1. Carry 0. 3. 1 plus 0. Sum 1. Carry 0. 4. 1 plus 1. Sum 0. Carry 1. Let us take any two binary numbers and add them. Example. 00111010 with base 2 plus 001100 with base 2 is equal to 00100110 with base. Binary subtraction. The result obtained after subtracting two binary numbers is the binary number itself. Binary subtraction is also the simplest method to subtract any of the binary numbers. It can be calculated easily if we know the following rules. Rules: 0 minus 0 is equal to 0. 0 minus 1 is equal to 1 with a borrow of 1. 1 minus 0 is equal to 1. 1 minus 1 is equal to 0. Rules for binary subtraction. Case 1. A minus B. 0 minus 0. Subtract 0. Borrow 0. 2. 1 minus 0. Subtract 1. Borrow 0. 3. 1 minus 1. Subtract 0. Borrow 0. 4. 0 minus 1. Subtract 0. Borrow 1. Example. 00111010 with base 2 minus 001100 with base 2 is equal to 00001110 with base 2. Binary multiplication. The binary multiplications are calculated similarly as the other arithmetic numerals are calculated. Let us take any two binary numbers and multiply them. It can be calculated easily if we know the following rules. Rules: 0 multiplied by 0 is equal to 0. 0 multiplied by 1 is equal to 0. 1 multiplied by 0 is equal to 0. 1 multiplied by 1 is equal to 1. Rules for binary multiplication. 1. 0 multiplied by 0 product 0. 2. 0 multiplied by 1 product 0. 3. 1 multiplied by 0 product 0. 4. 1 multiplied by 1 product 1. Example: multiply 100 with base 2 with 111 with base 2. Hence, 100 with base 2 multiplied by 111 with base 2 is equal to 11100 with base 2. Binary division. The method of binary division is similar to that of 10 decimal system other than the base 2 system. It can be calculated easily if we know the following rules. Rules: 1 divided by 1 is equal to 1. 1 divided by 0 is equal to meaningless. 0 divided by 1 is equal to 0. 0 divided by 0 is equal to meaningless. Rules for binary division. Case 1. A divided by B, 1 divided by 1, division 1. 2. 0 divided by 1, division 0. Example: divide 110 with base 2 by 10 with base 2. Quotient 11, remainder 00. What are binary arithmetic operations? Addition. 1. 0 plus 0 is equal to 0. 2. 0 equals 1 equals 1. 3. 1 plus 0 equals 1. 4. 1 plus 1 equals 10. Subtraction. 1. 0 minus 0 equals 0. 2. 1 minus 0 equals 1. 3. 1 minus 1 equals 0. 4. 1 minus 0 equals 10 minus 1 with borrow 1 equals 1. Multiplication. 1. 0 multiplied by 0 equals 0. 0 multiplied by 1 equals 0. 1 multiplied by 0 equals 0. 1 multiplied by 1 equals 1. Division. 0 divided by 1 equals 0. 1 divided by 1 equals 1. 0 divided by 0 equals not allowed or not valid. 1 divided by 0 equals not allowed or not valid. Flashback. The method to represent and work with numbers is called number system. There are 4 types of number systems, namely decimal number system, binary number system, octal number system, and hexadecimal number system. Decimal number system uses 10 digits, that is from 0 to 9. Binary number system consists of only 2 digits, that is 0 and 1, and it has a base of 2. Octal number system consists of 8 digits that varies from 0 to 7 and it has a base of 8. Hexadecimal number system consists of 16 digits and letters. The digits vary from 0 to 9 and letters vary from A to F. We can convert decimal numbers into binary numbers into decimal numbers into octal numbers, and decimal numbers into hexadecimal numbers. 4 types of arithmetic operations are performed with binary number, that is addition, subtraction, multiplication, and division.